Here is part 2. Now don't worry, if we don't get through all of the lesson, I will be back tomorrow to kind of review it. If you haven't seen it already, the test is not slated for until Thursday.
What kind of crazy weather do they have here? I thought it was supposed to be summertime.
Crikey, it must be a heat wave in the middle of winter.
A formula is an equation that consists primarily of variables. Each variable in the equation represents an important part of the relationship expressed by the formula. Sometimes you need to rewrite or transform an equation to isolate a particular quantity to solve a problem. Consider the following situation. The Celsius and Fahrenheit temperature scales are related by the formula C equals 5/9 times the quantity F minus 32.
Now this is an equation that's just given to you. It's kind of a conversion one, so you don't need to memorize. If we ever applied it on a test, I'd give you the equation.
C represents degrees Celsius and F represents degrees Fahrenheit. Suppose you are asked to convert several Celsius temperatures to Fahrenheit temperatures. In this situation, it is helpful to rewrite the formula so that F is isolated.
Just to remind you, for Celsius and Fahrenheit, it's just a different unit of measure. For temperature, depending on what part of the world you're in, they use different things. Most world places use Celsius, whereas we use Fahrenheit to understand our temperatures.
Then all you have to do to convert the Celsius temperatures is to substitute them, one at a time, for C, and simplify. Solve the formula C equals 5/9 times the quantity F minus 32 for F.
We say plug and chug.
To solve for the variable F, use the steps you already know from solving 1- and 2-step equations. Write the original formula. Multiply each side by 9/5, the reciprocal of 5/9. Simplify.
Now we're going to take a quick brief pause to kind of talk about this right here. It may seem kind of complicated, but let's imagine it being x is equal to 1/2 y. Well, we know if we want to get rid of this divide by 1/2, you would do the opposite of multiplying by 1/2, that's divide by 1/2. But we know that dividing by a fraction is the same thing as multiplying by the reciprocal, so KFC. That's the reason why that works right there. Okay? This is, again, something that we learned in the past, coming again. Hopefully you learned it right the first time.
Add 32 to each side.
You should know how to do that.
Simplify. The new formula is F equals 9/5 times C plus 32. Now you're ready to convert Celsius temperatures to Fahrenheit temperatures.
A lot of the times we say that this is isolating the variable. So we say it's solve in terms of F or solve in terms of C. So it's manipulating the equation to get what you need. Here we have a spacecraft Magellan that was launched on May 4th, 1999. And during its 463-day flight to Venus, it traveled about 806 million miles. So if distance equals rate times time, and they want us to find the average speed of miles per hour, round your answer to the nearest hundredth. So we want to find it in terms of, for R. We want R is equal to. That's what they're saying. Solve in terms of R. So what's by the R that you want to get rid of? You see that there's a T, and what sign is it? That's multiplication. So you want to divide both sides by T. So in the equation for rate, it's basically distance over time. Some of you guys will understand that. We'll kind of clarify tomorrow after doing a couple to see how we do that. But what they're doing is they're rewriting the equation so that this is what you're solving for. Now it's easier because you're just plugging in what you need. You're going to plug in the distance, which is 806 million. So rate is equal to 806 million miles, and we're going to divide that. I don't know if you want to write it out. That's a million, and you can use your calculator. Divide by the time, which is 463 days. That's pretty much what you do. You can type in your calculator, and you should get the wonderful answer that's going to be shown right here, which ends up to be about 72,500 miles per hour. Oh, they want us per hour. Okay, so what we did, well, once we do 806,000 divided by the thought about re-recording this, but I like it when we make mistakes. 463 days. That would calculate, let's see, the distance over days. Okay? But what we're saying is we want to know per hour. If we want to know per hour, we have to convert the days into hours. So we know that there's 24 hours in a day, and we're going to multiply that by 463. So that's going to get us what's underneath right there. It's a very innocent and honest mistake. So let's go back to the solution that they have right there. See if you can beat me there, and that is that's how we get the 11,112 hours, because we multiplied how many hours per day. So then that's how we get that answer right there. So hopefully that makes sense. If not, again, ask questions tomorrow. And then the key thing is you have to try it in order to really understand it. Orcas swim at a rate of 700 feet per minute. Solve the distance formula for time. So I want, first part, they want t to be equal to something. See if you can do that, and then plug in the things that you need to. Pause. Unpause. Hopefully you know t is distance over rate now. So now we can probably plug in what we need. Find the time it would take for the orca to swim 2,400 feet. And this is the rate, so we know that time is equal to 226,400 feet. We're in the same unit, so we're talking about feet and feet. That's good. Over 704. Plug that into your calculator, and you should get the magical answer that's shown right here. And that is 37.5 minutes, because we're talking about minutes here. Okay? Do we have to do, I don't think we have to do any conversion whatsoever here, because it's per minute. So that is part 2 in the wraps.